Hello everyone, today we are going to talk about insulation resistant testing for transformers. The insulation resistance test assesses the quality of a transformer's insulation. The insulation prevents leakage currents from flowing between the windings and to the ground. Its objective to detect insulation degradation, often caused by moisture ingress, aging and heat stress, contamination and mechanical damage. We have 5 steps. The first step is to isolate and disconnect the external connection, high voltage and low voltage connections. Step 2, discharge windings using a grounding stick and wait for a few minutes. Step 3, clean bushing to ensure surfaces are clean and dry. Step 4, short circuit windings, the high voltage terminal together and the low voltage terminal together. Step 5, ground the tank with a solid earth ground. We have 3 types of tests. The first one, the low voltage to the body. Test 2, high voltage to the body. Test 3, high voltage to the low voltage. We can see that in this diagram the 3 types of testings. We have the mega ohmmeter device. It has 3 points. We will use the line and earth points. In the first type, we are going to connect the short-circuited high voltage side to the L point of the mega ohmmeter, and we are going to connect the short-circuited low voltage side to the A point of the mega ohmmeter, and we are going to measure the insulation resistance for 1 minute. In the second test, we are going to connect the short-circuited high voltage side to the L point of the mega ohmmeter and the E point to the transformer's body, which is grounded to the earth. And in the third test, we are going to connect the short-circuited low voltage side to the L point of the mega ohmmeter, and we are going to connect the A point to the transformer's body or tank, which is grounded to the earth. We will compare the baseline. We must compare two baseline values, like we check against factory or previous field results. We apply 1 mega ohm rule, which implies that the minimum insulation resistance must be equal or close to 1 mega ohm per 1 kilovolt operating voltage, and the absolute minimum is 1 mega ohm. The acceptance criteria: when it's well above minimum values, it's considered good. When it's close or slightly below minimum, it's questionable. When it's significantly below minimum, it's unsatisfactory. And we can use the polarization index for larger transformers and the moisture assessment. It's a reliable indicator of insulation quality. It's calculated by dividing the 10-minute reading by the 1-minute reading. When the polarization index is higher than 1.5, it's considered good. When it's between 1 and 1.5, it's questionable, and when it's lower than 1, it's considered poor. And as we said before, it's used for larger transformers and moisture assessment. Thank you guys. So subscribe, like and comment.